Hello friends, my name is B K Kolhapure. I am from PD College of Engineering, Gulbarga. So today we will be handling the topic on equilibrium of forces. Before going to this topic, I would like to just review what are the things you have learned till now. So you have studied two systems of forces, concurrent force system and non-concurrent force system. In concurrent force system, all forces are meeting at a point. All forces are meeting at a point, and in non-concurrent all forces are not meeting at a point. So these are the non-concurrent force system. In both the cases, what you have done is you have found out the resultant of the system of forces. Resultant of system of forces. Now what is a resultant force? If there are a number of forces acting in a system, you can replace all this system of forces into a single force. This single force is known as the resultant force. It will have the same effect as produced by the system of forces. Number of forces converted into a single resultant force. Now here we have found out the resultant force for concurrent force system as well as for non-concurrent force system, and the formula what we have used to find out the resultant R is given by under root of sigma h square plus sigma v square, where sigma h is horizontal component of all the forces and sigma v is the vertical component of all the forces, and the angle made by the resultant with horizontal tan theta is given by sigma v by sigma h. If it is concurrent force system, these equations are enough to find out the resultant of the force of system, because the resultant will pass through the point of contact of all the forces. But in case of non-concurrent forces, you will be finding out the resultant and you are supposed to know the location or the position of the resultant force. For that, you will be using Varignon's principle of moment. It states that moment of the resultant force is equal to algebraic sum of moment of all forces. So in that case, you are going to find out the moment of the forces. So you will have to find out three things to find the resultant of a force of system. One is sigma h, 2 sigma v, and 3 is sigma m. So sigma h you will have to find out, sigma v you will have to find out, and sigma h m you will have to find out. For concurrent only these two are sufficient. For non-concurrent all these three has to be calculated. Now if I come to concurrent force system, if sigma h is 0, then what is left out is R will be equal to sigma v. If sigma v is 0 and sigma v h is existing, then sigma v is 0, then R will be equal to sigma h. If sigma h is 0 and sigma v is also 0, then what will happen to the resultant? 0. Now out of 3, these two are 0. Sigma h is 0, sigma v is 0, but sigma m is not 0. In such a case, the system will be converted into a couple. Resultant 0, moment not 0, the system will convert into a couple. If sigma h is 0, sigma v is 0, and also sigma m is 0, then nothing will happen to the system. We say the system is in equilibrium. Now when is the system in equilibrium? When sigma h is 0, sigma v is 0, and sigma m is also 0. We call these are the conditions of equilibrium of forces. So what are the conditions of equilibrium of forces? Simple. Sigma h is 0, sigma v is 0, and sigma m is also 0. Then we say the system of forces are in equilibrium. Now suppose further going, if there are two forces acting, one is P1, another is P2. Both are acting at a point. If they have to be in equilibrium, then P1 must be equal to P2, opposite to P1, and they should be in one line. So if there are two forces, then one force must be equal, opposite, and collinear to the other force. We have seen in the resultant problem, if I say this P1 is nothing but R, resultant, so you have studied another term known as equilibrant. So what is an equilibrant? A force equal, opposite and collinear to the resultant when added to a system will bring the system in equilibrium. So these are the two forces acting. Suppose if there are three forces acting like this, one P1, P2 and P3. If this system of forces has to be in equilibrium, then if I consider any two forces P2 and P3, if I find out the resultant of this P2 and P3 as R, then the resultant of two forces must be equal, opposite to the third force. Or if I consider P1 and P3, if I find out the resultant of P1 and P3, then this resultant must be equal, opposite and collinear to P2. So like this system of forces are in equilibrium if there are three forces. Suppose there are four forces like this, P1, P2, P3 and P4. If this system of forces has to be in equilibrium, you consider any two forces P1 and P2, find its resultant as R1. Similarly, other two forces P3 and P4, find the resultant of these two forces. This will be equal to R1. So resultant of any two forces must be equal to the resultant of the other two forces in opposite direction. Or instead of these two forces, if I consider P1 and P3, if this is the resultant R, if I consider another two forces P1 and P4, if I find out the resultant of these two forces, resultant of any two forces must be equal and opposite to the resultant of the other two forces. These are known as the four force system. So this will be using in knowing the theory behind the then we have seen conditions of equilibrium are sigma is 0, sigma v 0 and sigma m is also 0. Now we come across a theorem in this chapter known as Lami's theorem. Lami's theorem. You already studied this in PUC. We will be repeating it here again. This is the only theorem that is available in the whole chapter. So be thorough with this Lami's theorem of equilibrium. It states that if there are three forces acting, P, Q and R. If there are three forces acting P, Q, R simultaneously at a point O, if alpha, beta and gamma are the angles. Now see how that angles are there. If P1 is the force, these Q and R are the other two forces. So the angle made between these two forces, if I call it as alpha. Now Q is the next force, the other two forces are these two forces, and this angle is called as beta. And if I consider this third force R, these two forces will make an angle beta. Now the statement says that if P, Q, R are the three forces simultaneously acting at a point are in equilibrium, and alpha, beta, gamma are the angle made between the other two forces, then the force P is proportional to sine of the angle between the other two forces. Which is the force P and what is the angle between the other two forces? Alpha. Likewise, any force Q is proportional to the sine of the angle between the other two forces. What are the other angle made between the other two forces? Beta. Likewise, R, third force, is proportional to the angle between the other two forces is gamma, sine of gamma. Or in total, we write P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. This is known as the Lami's theorem of equilibrium of forces. Remember, I will repeat the statement. If three forces, remember three forces maximum, if three forces are acting at a point are in equilibrium and alpha, beta, gamma are the angle made between the other two forces, then P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. This is the Lami's theorem of equilibrium of forces. Now derivation I have already dealt it in the earlier portion, so I will not go with the derivation. So directly I will go with the problems in the next class. Okay, thank you.